good day to everyone. We are from University Ternate Malaysia, Department of Electronic Engineering. Today we're going to perform on a group project on electrical circuit 2. Aim of this project is to perform circuit analysis techniques for a given AC network problem using suitable simulation approach. Objective of this project will be to investigate the response of an RLC series circuit, a sinusoidal excitation, and a step excitation under conditions of underdamping, critical damping, and overdamping. To stimulate a second order RLC circuit using any electronic circuit software. So we are using multi-sim, and also we are demonstrating a video format of the circuit stimulation. Case 1 will be to identifying the underdamping, critical damping, and overdamping. For that, we have to build three different types of circuit. As we mentioned in the objective, our circuit will be RLC series circuit. So RLC series circuit will be using a power source, DC power source, a resistor, inductor, and a capacitor with a ground. As we can see in the demonstration, once we are done collecting the resistor, capacitor, inductor, ground, and the power source, we have to connect it, and as same we're going to form three different type of circuits with the three different types of values of resistor. So the given omega for this project will be 10 crate per second. So once done constructing the circuit, we're going to change the values of capacitance, resistor, so that we can get a perfect graph on overdamping, critical damping, and underdamping. Once done constructing the circuit, we can start running it. So this will be the result for the constructed circuit. So as can see in this graph, the green color line will be underdamping, blue color line will be critical damping, and the red color line will be overdamping. Case 2. Case 2 will be designing a circuit for an overdamp response, critical damp response, and an underdamp response on given circuit model for ignition system. On this project, we're going to plot the responses, including the time interval just prior to moving the switch. And finally, we're going to verify the design on overdamp, underdamp, and critical damp. And we have to determine the inductor, capacitor which produces the current response. As we can see, there will be a power source, switch, capacitor, inductor and a resistor in this circuit. So as can we see, we have to construct 3 different types of circuits for 3 different types of designs, which is critical dam, overdam and underdam. Okay, as we can see, once done constructing the circuit, we're going to change the value of capacitor and inductor as shown in the video. Once changing it, we're going to start run the circuits. So this will be the circuit. So the red color will be for overdam, green color will be critical dam and the blue color will be underdam. So as we can see in the graph, all 3 graphs are increasing and then later it's decreasing as time goes on. This is because when it's going up, capacitor is releasing the charge from it to the circuit. Once all the charge is used up, it's going back to 0 value. So the graph is proved correctly. As we can see, once we on the switches of the circuits, we're going to take the initial conditions, which will be 12 volt. Once done, we can run the circuit. So as we can see in this graph, all the 3 graphs is decreasing and increasing. So while it's decreasing, all the capacitance are charging, and once all the capacitor is charged fully, it's getting back into a constant steady state as shown in the graph.